Hello everyone. Today I am going to start CSES advanced techniques. Let's look at the first problem. Meet in the middle. So you are given an array of n numbers. In how many ways can you choose a subset of the numbers with some x? Here n is up to 40 and number can be up to 10 to the power 9 and like x can be up to 10 to the power 9 and the array element can be up to 10 to the power 9 also. Now here if n is up to 20, then what you can do is basically you can try all the possible combinations and count the number of times some x occurs. So here n is up to 40. Now what to do? So I am going to explain. If you want to try, you can try. So in this problem, as n is up to 40, then what we can do is basically take, let's suppose I am going to solve for n equals to 40. Divide the array into two parts, both containing 20 elements, and both are disjoint. Now what you do is basically find all the possible sums that we can generate from the first array, store it in a vector, and also find an second all possible sums that can be made using elements of second vector. Now we have two vectors and we have to uh, count the. Now the question is basically we are having two array and we have to mm, count the sum of numbers with some x. So let me explain. Let's suppose these are number 40 numbers. What we did, we divided it into two parts, one containing 20 elements, other containing 20 elements. Now we find all the possible sums that we can generate using the first part, this one, this part, and from the second part here. Now the only combination that remains is basically taking elements from this part and from this part only this remains. We have to count this possibility also. Now the answer will be the number of times x occurs in this part, I mean this part, number of times x occurs in this array, which is basically all the possible sums we can generate from the first part, and plus the number of times in this in this occurs, like number of times x occurs in this part. Now let's suppose there is a sum in this part which is basically p, and there is a sum in this part which is basically k minus p. Now if we pick one element from here, like with this p from here and this k minus p from here, and add it, then we get the sum x. Let's suppose this is x, then we will get x. And if you see that this is a subset of the original array, complete whole array. So by taking all the possible elements from here and finding whether k minus p exists in here and counting all these pairs, we can get the count of x, number of times x occurs. So basically what we have done is basically we have founded all the number of times x occur in this part, number of times x occur in this part, and And what I am going to do is basically taking some subset of this part and taking some subset of this part and checking whether sum is equals to x or not, which is equivalent to taking some subset having some p from here and some subset having some k minus p from here and adding and getting x. This will be counted. So the question is now solved. uh, Fine, what we will do is basically first let's see the implementation part. This is the array. We will divide into two parts. Let's suppose this is up to 20 elements and the remaining elements here, and we find out all the possible sums that we can generate from here. uh, as CSE is basically CSES, time constraint is very like it is only 1 second, then you have to optimize your code as much as possible. So first what we will do, we will store a pair. We are going to store a pair, like pair means store element xi and its frequency, like sum si which we can generate and number of times it occurs for all, and which is basically sorted, which is basically sorted. Now we will get two such array, like one from left and one from right. Now we will do two pointer. I will put one pointer here and one pointer here, and I will iterate on this array, and if I am at some element here, then I will move this pointer to the left until we get element. Let's suppose this is si and fi, until we get x minus si here. If it is not, then I will move to here and correspondingly update the answer, corresponding counting all the possible combination. Now let's look at the code. So here basically I am taking the input n and k. Basically k is here x, and what I am doing is basically in v1 contains first 20 elements and v2 contain the rest of the elements. Now count of 1 stores the sum which will be generated by vector v1, and count 2 stores the sum will be generated by vector v2, and pre is the function which calculates it. So pre takes two argument v and count, and basically it goes over all possible combination like I equals to 0 to 2 raised to power n, and basically from j, like checking all the bits, like if I am at currently at I, then I will write it in binary. Let's suppose it is 0 1 something like that. Then the whichever bit is 1, I will pick that element and add it to the upper sum. This is the one of the sum which can be generated from this vector, and I am pushing it in TMP. Now we don't now for optimization we have to make element and its frequency. For that, what I am doing, until I am sorting the TMP vector and iterating over the TMP, and until the last element is equals to the previous inserted element, we are increasing the previous element frequency. Otherwise we are inserting with frequency 1. Now we calculated count 1 and count 2. Now j is a pointer, and it is I am iterating over the first array count 1, and currently the remaining what we wanted is k minus it dot ff, is basically k minus the current sum, k minus si. and I am moving the pointer J left towards left until the current element is greater than remaining. If j equals to minus 1, we are breaking it. Otherwise, if the current element is equals to remaining, we are adding the corresponding frequency. Like if it dot ff occurs it dot ss times, and count of 2 of j dot ss is the frequency f2, then the total frequency that will be added is f1 into f2, and finally printing the answer. So thank you.